So I wanted to try my hand in inventing my own numbers, similar to how old mathematicians invented imaginary numbers in order to try and describe and come up with a solution for the problem of x squared equals -1. There's also this weird number which is squared by itself equals 0 but doesn't equal to 0, which is represented by epsilon, which I watched a video that someone else made about it, and I've watched a lot of videos about just about the weird and wacky world of numbers and different types and how we define them. There's also this one video where there's these star numbers called nimbers and whatnot, and I just wanted to try my hand at either making my own number a unique function that does whatever the heck it does, that kind of thing. The thing is that most numbers can just be represented using matrices and vectors. However, I have not gotten that far into math to even bother with it, and I'm just doing this shit for fun. So whatever the hell happens, happens. The thing that I wanted to kind of do was try and make a number that was kind of impossible to kind of exist, because that's not how this shit works, but hey, I mean, I'm just doing this for fun. Who gives a shit? My question is basically we usually can't allow a function to output two numbers at the same time, because, the square root of x, the y equals the square root of -x, the function is effectively just the one line over, but it's the same thing similarly as x equals y squared, but it only covers the positive half, while the other half is just completely erased from existence itself. And I couldn't help but, and it's just kind of those two things are the same thing, and yet somehow it doesn't work because of the property of square roots and blah blah blah. It fucks with my head, right? The thing is that there is kind of something that equals two numbers simultaneously. It's basically the plus minus symbol in math that basically says this number can be either plus or minus this amount, and that's kind of about it. And we can kind of generalize it so that way x can be any two values by basically, taking any two values on the number line, then, finding the midpoint, and then plus minusing how far it is from that midpoint. And so basically you have some, if you let the variable we're going to use x because that's, we always use that in math class, so fuck it. Let x equals, this number that's effectively plus minus this much, and then you see the visuals. You probably understand that more than my random gibberish of me trying to explain what's going on. Sorry for all the blind people who can't read what I've shown on the screen. So my question is, can I make a function or something that x equals to such that it will be equal to three values simultaneously? And, well, the thing is that, well, I'm gonna try and settle on trying to get x to equal three numbers at the same time through this function, because I'm gonna presume that I can build upon it and go to 4, 5, 6, and whatever by just adding one extra thing to it, because most math kind of just involves binary operations. Addition always involves two numbers, and even if you add 3, 4, 5, all the numbers together, it all kind of I forget the exact term, but basically it doesn't matter which order you add them all in, it's going to be the same freaking result. That's why you have the order of operations and whatnot. Multiplying the same huge amount of numbers is going to be the same thing as multiplying any of the two numbers within that huge sequence together. And honestly, I have no idea if this number even satisfies anything within math or whatever bullshit. I don't even know if it has any applications into real life. This is literally just complete bullshit. Then I thought about polynomials and how in their more simpler forms it's x minus 2 times x plus 5, both of those separately in parentheses, of course, and all of those equal to 0, and it can be satisfied by either 2 or -5 in order for it to be 0. So x can be either one of those two values to state this equation, or honestly it could be both and would satisfy the equation because it's all getting all that stuff. So then I thought to myself, alright, so if we had a cube root, and then we have x minus a, x minus b, x minus c, where a, b, c, and so on, d, e, e, f, we could include this, we could literally go forever, where the solution that x has to be could be literally all these numbers, but typically it's just kind of if we're thinking about like x as like this solution thing, but I'm trying to find also just a sort of function that would define three separate variables all at once, right? And I am not sure how to even begin doing this because, like, what function or combinations of functions would be able to get x to equal all of the solutions to the roots of any polynomial equation? Power 3, 4, 5, etc. What function basically split? It's like a few values here and there and outputs a huge amount, you know? Then I remembered that the cube root of 1 technically has 3 answers and it's not just 1. If you allow for more complex solutions, there's actually 3 different roots that it can equal to. So if we treat the cube root of n, where a is a real solution, b and c are like omega and omega squared, such that when you square by another omega, you get omega 3, which is the same thing as the real solution, the main thing. It basically means that we have, like, if x equals the cube root of some value, then we get 3 exactly different outputs. It basically equals the 3 different values, and the problem is kind of solved then, because, well, if I wanted, like, if I wanted a number to be equal to multiple things, then I would just apply an nth root function depending on how many outputs I want for it. However, I encountered a new problem where how do we get x to equal 3 specific values that we want x to be equal using cube roots? And so I tried to think about it by trying to use, like, I want x to equal 3, 4, and 5 by somehow using a cube root, like 3 to the power of 1 or something. And I tried to come up with a general solution where it kind of doesn't make any sense anyway, so here I am just trying to pop up a solution here. But, so I try to think about it in like a different way, where rather than like try and have a specific function defined, I just use the cube root as the function itself, and all 3 implied solutions to a number, any given number, is effectively the outputs. But I'm still kind of stuck trying to make it interact with another value. 2 or 3 things that, I can't really come out the top of my head. There's no like specific number I can really add, so that way it turns into a specific number-y thing. And then, like, because, like, if you just add a constant value to a cube root of anything, all you're gonna do is just shift it left and right. Like, you're just gonna be moving the solutions left and right, and if those are your 3 specific values, that's cool, but how am I gonna, like, twist, turn, bend, and do all sorts of things with these values so that way I'm able to get to the 3 specific values that I want at any distance that I want? So I then thought, hey, why don't we try using the square root, which outputs 2 values, and then, like, try and use those 2 values to affect the 3 values that are outputted, but instead it just kind of ends up creating 6 values. And honestly, we can shift them back and forth because we can define any of the 2 values that the square root can be by using L as, like, the middle ground, right? So it's just kind of there. Yeah. So then I figured, you know what, I'm going to ask Wolfram Alpha, since I remember that I believe that AI could do all the freaking complicated math for me in the complex math, so maybe there's like some complex function that kind of gets me 3, 4, and 5 by multiplying the cube root and whatever, but it didn't understand my question no matter how much I tried to rephrase it. And then I kind of had the idea by looking at the plot of it that, hey, why don't I just make a plot and maybe that might give me some insights, and it sure as fuck did not. Even for stuff with like 3 values, like tri-valued logic, 3-value logic, it does just use binary functions. Like it takes 3 different values and does stuff with it, but it only takes like 3 types of values. But at the end of the day, it only works with 2 logic variables, two logic values, not 3 all at once. And it can all be simplified down to like binary and binary, and now I'm just There's literally nothing that works with three values all at once in the entirety of math because we all simplify it down to two things, and I can't really use the two things, at least within my current skill level, to get three specific values using cube roots, which is my current only lead to kind of get to like some kind of thing that equals three separate things. Then I kind of thought to myself, hey, maybe I should multiply by a complex number or just by I, but honestly, the only thing that's gonna do is just rotate the entire freaking thing around, all the three values around the same point, and it's not gonna really let me select three specific numbers from the number line. So I'm stuck again. And then you might be thinking to yourself, well, if you multiply and like do stuff with imaginary numbers, it can transform a little bit, it can stretch it and do stuff, but then it kind of becomes a problem of like, can you move a triangle in like any way such that... Actually, wait a minute. I don't even need to do math for this shit. This is a geometry problem. Can you rotate a triangle so that way, given like any 2 points, you can like fit the thingy in the thingy, and then like the points on the triangle, like you can. But unfortunately, I think I've come across with another problem where basically, given any like nth root of 1 or any value, honestly, all the roots effectively form a regular polygon. And, well, the regular polygon for fourth root is a square. And we can't, I don't believe we can make or shift it so that way we create like a trapezoid or a any like quadrant, like one arbitrary quadrant, quadrant. Look, it's been a while since I've been in school, right? Fuck off. So now the new problem effectively is like, can we use a square to like pick any 4 numbers on the number line? Like we can have like 2 values that are like super close to one of the values, and then like the other one's like super far off into the distance, completely far off. And personally, at that point, I don't think that's a square anymore. Like 3 points, like the sides aren't even at the same distance at that point. And like, no matter how far, like how big you make the square, there's no way to really do that. So, unless you like use infinities, I suppose, but like, now the new problem is basically like, can you make something such that it will a variable with the value of like 4 or more, like how many simultaneous numbers can you kind of create with anything, and can like select any 4 or 5 n amount of numbers and have it all kind of make sense like that. I honestly thought that was going to be where it was going to end, but then I remembered matrices are the next freaking step in this goddamn huge complicated problem of hell that I've made for myself, and turns out that we can shear shapes with matrices, and I decided to look it up, and apparently some people actually managed to make a way such that you can turn a square into any sort of quadrilateral. That's what it is. I'm making this video as I go and editing as I go, and that practically solves my problem for the fourth root. So yeah, now you can find literally, you can pick any 4 values along the number line, create a quadrilateral that kind of hovers above it using a square, then shearing it, and then doing all sorts of transformations to it using a matrix and some complex values and stuff or whatever, and then just going from there. Now the next problem would be, can you turn a regular pentagon into any pentagon, and then the same thing goes for a hexagon, and then a heptagon, and so on, all the way up to infinity using matrices at that point. And unfortunately, I have not gotten into linear algebra or matrices that deeply yet to even try to begin on a solution, and when I looked it up, I don't even think anyone has even tried that, so as far as I freaking know, who freaking knows? And the interesting thing is that I'm pretty sure there is probably a solution, but it's way beyond me. And all this is just yeah, I guess I've pretty much reached my answers. Technically, you can make a number you can basically make a number that just makes infinite amounts of values. Technically, 5 plus is still kind of I guess somebody has to prove it for certain, or for what I'm saying to be kind of true. But now what? Does anyone have like real life applications for this bullshit that I just made up? Like it's literally like cube roots and polynomials, but on a completely I basically just slapped all the polynomials and roots and stuff under a completely different name, somehow involved like complex numbers and matrices, and now I have something that is that. So, and honestly, all of it can literally be simplified by like the first root rather than like literally anything. So it kind of ended up being completely pointless anyway, because like most math is would find like almost the entirety of almost all that bullshit completely worthless. So anyone got any bright ideas? Because I sure as fuck don't.